Today we are going to discuss about the mathematical analysis for non-recursive algorithm. So we know what is non-recursive. A function which doesn't call by itself is called as non-recursive algorithm. So now we are going to discuss two examples of non-recursive algorithm. First let us discuss the example of finding maximum element. And then we will discuss about the finding unique element. So both the example I have taken from prescribed book Anani Levitin. So here mathematical analysis of non-recursive algorithm. In this we are going to analyze the time efficiency of non-recursive functions. So for example, for maximum, finding maximum element, how we can analyze the time efficiency. So that we are going to discuss now. So for finding max element, the basic logic is we are going to find the maximum element from a given array. So let us take an example. So there is a size of array is 5. So the index starts from 0, 1, 2, 3, 4. So in these indexes, for example, we are storing the value 50, 30, 35, 20, 10. So among this 5 number of element, we have to find out at which location the maximum element is found. So we doesn't know where the element is, maximum element is found. So here we are going to write a logic, that is algorithm, how we can find out the maximum element from the given array. So first we have to write a for loop, because using for loop only we can able to find at which location the element is, maximum element is present. So we have to start from 0. We have to check whether the element, first we have to store this maximum, the first element into some variable. So use a different variable. Here we will assume it as max value. So in max value, index a of 0th index, what are the values present at 0th index, so that we can store it into max val variable. So then we have to start from the first index. So for 0th index value we have stored into max val variable. So now we have to start by comparing the 0th index value is greater than the first index. So then suppose if the index, first index value is greater than 0th index, then we have to put it into max val variable. So likewise we have to keep on checking whether the max value is greater than second index and max value is greater than third index. Likewise we have to go till the last index value, which is n minus 1. So we have n value is 5. So we have to go until n minus 1. So because we are starting the index from 0, so we have to go to until n minus 1 location. So for loop, using for loop we have to check for I equal to 1. So why 1 means, because already we have taken from the index 0. So next we have to start checking from this index, that is from the first index. So we have to write I equal to 1, 2 up to last index, which is n minus 1. Okay, so then from this location we are going to compare with the last location. Next we have to write the comparison operation. So here what we are going to check, if a of I is greater than max value, so that is the value whatever we have stored in max value is, we are going to check with this a of I. a of I, the value what is there in a of I, that is first location, because we have to start from a of 1. So a of first location, here we have 30. So 30 is greater than max value. So here I will write at first iteration. At first iteration, whenever the I value is 1, here we have to check whether a of 1 is greater than max value, which is 30. So here max value already we have taken it as a of 0. So a of 0 contains value 50. So this one we are going to check here. So here a of 1 is what? A of first index is having the value of 30. So here we have to check 30 is greater than 50. So here the condition is false. that is not greater than 50. Next, I value will get incremented by 1. So now I value is 2. Again we have to compare a of I is greater than max value. So a of I is, which is a of 2 is 35. 35 is greater than max value which we have 50. So 35 is greater than 50, condition false. So again I value will get incremented. So this I value will keep on incrementing until it becomes I less than or equal to n minus 1. So now I value will become 3. Again check a of I. So here we have to check 3 is less than n minus 1, which is 4. So 3 is less than 4, condition true. So go to inside this for loop. If a of 3 is greater than max value, a of 3 is 70 and max value is 50. So here the condition comes true. So condition true means then it goes inside this if function and then substitute max value equal to the value whatever it is there in a of 5. A of 5 we have 70 because I value now it is 3 and a of 3 which is 70. So that value 70 can be stored into max value. Okay, again I value will get incremented. Now I value will become 4. So now check 4 is less than, so this is less than or equal to. So 4 is less than or equal to 4. Again here the condition is true. Condition true means come to this statement if a of 5, a of 4, a of I is 4. So a of 4 is 10. So 10 is greater than max value. What value we have now? So we have updated value which is 70, not 50, because here in previous iteration the condition comes true. So we have stored 70 into this max val variable. So that we have to write 10, that is a of I which is 10, a of 4 value is 10 and greater than max value is 70. Now we have to find out the time complexity of this non-recursive algorithm, which is finding max element. So when we want to find out the time complexity, we can represent in terms of C of n. So then for finding the time complexity, we have to write summation of and lower term. Lower term and upper limit we can take it from this for loop, which is 1 to n minus 1. So when 1 is a lower limit and n minus 1 is a upper limit. So we can write it as I equal to 1 to n minus 1. And here these are the three things we should know before finding the time complexity. So what is the input size, what is the basic operation, and how many times this basic operation is going to be executed. So input size is here 1 to maximum n minus 1 times the operation is going to execute. So basic operation, what are the basic operation here? Comparison and assignment. So here within this for loop we can see comparing a of I and max value until I less than or equal to n minus 1. And one more operation is assignment. So comparison, assignment are the basic operation in this program. And how many times this operation is going to execute is, so here you can see in each and every iteration. So I equal to 1, so comparison operation is executed. And I equal to 2, so comparison is executed. And I equal to 3, comparison executed, and also assignment operation also executed, because whenever the condition is true, then only this assignment operation will get executed. And likewise in each and every iteration only the assignment operation executes in all iteration. So how many times? One time. The comparison operation is going to execute one time for all iteration. So that we have to write here one time. This 1 to n minus 1 is, that is a lower limit from 1 to n minus 1, it is going to execute by one. Basic formula for finding the maximum element. So we know for this summation operation, we know the standard formula u minus l plus 1. So this is standard formula which we know already. And C of n, sum of I equal to 1 to n minus 1. So we have to use this formula and we have to substitute I equal to 1, which is lower limit is 1 and upper limit is n minus 1. So substitute u and l into this formula. So u is n minus 1 minus l value is 1 plus 1. So by cancelling, we will be getting n minus 1. And now the time complexity C of n equal to order of n. So we